for each institution. In this second part of the video, for Chapter 2, I'm going to illustrate the ETL process using the spreadsheet. Let's start. Let's first extract the data. I'm going to start with the Data tab. Click the Data tab, Get Data from text and CSV because the college scorecard data are in the format of TXT. So I'm going to open it and look for the location. So double click the data. You will see a new window pop up. It is called the Power Query window of the Excel. The first step is to look at this Excel pop-up window. It's the first 200 rows of your data set. You can see how your data looks like, and I'm just scrolling really quickly just to trying to see whether, for example, there are two columns merging together as one column, those kind of things. If the delimiter was placed correctly, there shouldn't be any two columns merged together. When you did your homework number 2, the textbook actually asks you to copy and paste the text data to the Excel spreadsheet. Now, using that way, it's different from what I'm doing right now. You can compare the two ways because now you know both. You can see when you are copy and paste all the text to the Excel spreadsheet, you will sometimes need to separate the columns by yourself. In the Power Query, it's basically separating for you if the comma was placed correctly. Okay, so I'm going to just transform the data. Click Transform. It pops up a new window. This is the Power Query. Power Query is relatively powerful in terms of processing the data set. I'll show you how. As I show you in the first part, my question would be trying to distinguish two groups of universities and their cost. So I need the admission rate and I need the cost of the university to attend the university. My first step when I see the Power Query is that I want to keep only the variables that I need to reduce the possible processing error, and I don't want to spend time on the variables that I don't need. So I'm going to only select the columns that I need and I remove other columns. And I also want to avoid throwing away information that I may need in the future. I'm going to show you how. I will select University ID on the name just to make sure that I can recognize each row what it is about. Although I may not need these data in my analysis. I will select admission rates, and as I said, I'll select the cost. I'm going to select some more variables that I need. Let's say SAT average and undergrad student number. Okay. I'm going to remove the rest, so I click remove columns and remove other columns. Now you can see my data set is nice and small, which holds only the variables that I need. What if I choose the wrong variable? Okay, if I realize that I did something wrong, I could always click this red X and remove let me show you. Remove it. It will go back to what I have done before I have done the selection. So I'm going to select it again. Now I redid the selection. With all the variables that I selected, I started to look at the variable type, the data type of each variable. I first look at the ID. University ID is currently a number format, but we all know that ID are not numbers because we don't need it to do calculations. So I'm just going to change it to the text. Now there's no right or wrong in choosing between text and numbers. You could choose text because if it's a 6-digit university ID and if it started with 0, then if you choose number, the first 3 zeros will go away. So you will be left with a university ID with different numbers of digits. That's when you use numbers. But if you think that's fine, you could use that. On the other hand, if you use the text, you will keep the digits intact, which is a 6-digit, even if it started with 0. Some of the inconvenience comes from when you write codes. For example, I use SAS. When I write a SAS code, if I want to filter out, for example, the first university, I would have to say if UNITID equals to the quotation mark 100654, and then write quotation mark. So if it's a text variable, I need to add the quotation mark. If it's a number variable, I don't. So you have to evaluate what you are going to do in the future to decide whether you want it to be a number variable or you want it to be a text variable. So for now, I think I want it to be a text variable because it's a category. It doesn't, I mean, it's an ID number. It doesn't have any calculation function for calculation. And looking at the emission rates, it should be either a decimal or percentage, but currently it's text. So I'm going to change that too. Now I can see some of other things that I may want to change are the same. So I'm going to change this to a decimal, or I could change it to a percentage. It's totally up to you. For the SAT average, undergrad, and the cost, they are all text number right now, TEXT. But you may want it to be, you do want it to be numbers because you are going to calculate, for example, the average, the mean, or some of the statistics. If they are text variable, you won't be able to do that. So what I'm going to do is that I'm going to change them all at once. If I have a couple variables, I can change them all at once. So I'm going to select all these. I can hold Control or I can hold Shift to select all these columns, right click and change type to whole number. Okay, these are whole number. Or I could do digital if I think they may have, the decimal, if you think they may have decimal after it. So I'm going to change to decimal. It's fine. All right, so that's the first step. Look at your data, look at the data types, keep the variables that you need, look at the data types, and change the data types to desirable data types. Next, let's talk about cleaning the data. We can see that there were some variables contain the null value of the variable. For example, some of the emission rates are null. What does that mean? That means this institution didn't report its admission rate to the database. So it's showing as null. The decision to make here is that what do you do with null numbers? Do you delete them or do you replace the null with 0? Okay, this is the decision you have to make, and it depends on the situation. In this case, in the college scorecard case, the null means the university didn't report this number. If you replace it with 0, it means the admission rate is 0. So which obviously it's probably incorrect. Especially with so many null variables in it, you won't think all of them are 0 admission rate, right? It's just considered that you just would consider that it's all missing. On the other hand, in one of the projects that I have done before, I was collecting all the footnotes from Chinese listed companies' financial statement. I was collecting the philanthropic donations that the Chinese companies made in certain years. So some of the companies do not report that number. So when you collect the data, it's also a null. However, does that mean that company does not have reported the data, did not report the data, or that company did not have incurred any donation expenses? If they didn't incur any expenses, they won't be disclosing it in the footnote. So we consult the CPAs in China, we talked to the practitioners, we decided it is basically no expenses incurred for the year for philanthropy donations. So we replace all the nulls to 0. Now you can see in these two different cases, I'm doing it differently because the meaning of the data are different. Okay, after we decided whether we want to replace the null value with 0, now we need to decide whether I want to delete the observations with null or not. Okay, how do I make this decision? First of all, it depends on the software that you are using. For example, in my research, I use SAS, SAS. When I'm running SAS, SAS does not consider all the null variables as existing. So when, for example, when SAS calculates the average of admission rates, it will consider all the nulls are missing variables. It will only use the non-missing variables, missing values to calculate the average. When I'm running regressions, it would also skip all the null values, all the observations with the null values in the admission rate, and run regressions with those with non-missing values. However, if you are using Excel, the situation is different because when you run a regression with Excel, Excel does not allow you to have null values in it. So you have to delete all the null values to be able to run a regression. I'm going to show you this when I talk about regression, and I'm not going to show you it right now today. Okay, so let's say I decided I have to delete all the null values. You will ask me, what's the problem? You can just delete it, right? Yes, I can just delete it. The only issue is that if I need this data set for 2 regressions, for example, the first regression used admission rate and SAT average, for example. Now, it has no problem because if I don't have admission rates, I can run a regression. So I should delete this observation. However, if in the same research project, in my second question, I use undergrad student number and the cost as the specification, right? So if I delete this third observation because admission rate is missing, then I lost this observation, which would have been able to participate in my second specification. Okay, now what would you do if you are using an Excel to run a regression? You could either make 2 different data sets when you are running 2 regressions, or you could always come back. You could run the regression using 1 data set and find out the result, and come back and edit your query to remove your steps that you take out those missing values in the first specification. So now I'm going to show you how to take out all the missing values in the database. The Power Query is actually very simple. You could just use this drop-down arrow and choose Remove Empty, right? Now all the missing value would be gone. And as I said, I need admission rate and the cost. So I'm going to remove admission rate and the missing value from the cost. Don't make your removal incorrectly, because if you also remove the SAT with null, you are now ended up with a smaller data set that you may have lost the information as I pointed out. So I'm going to remove the step that I'm going to remove the step where I take out the missing values in the SAT average, which I don't need to. So I'm going to remove that. Okay, now this is the data that I have already processed. Now I'm going to close and load the data. Choose Close and Load To. You can choose to load to a table or create a connection only. Let me show you what it does. When you create a connection only, you are only creating the connection that was the steps that you just have done. But you won't see the data because you didn't really load the data. Load To. So load to a table, and I'm going to use the existing worksheet, which is the first cell of this worksheet. Now this is my data. You can see I have almost 2,000 rows loaded. If you load the whole data set, you will see that's more than 7,000 observations, because I removed some of the empty rows for the variables that I need. So I have only left 2,000 rows. Okay, what's next? I have all my data here, but I don't know whether my data are correct or not. So I need to have some ways that I could check my data. One such way to check your data, of course, you can eyeball your data set, right? But if your data set is huge, for example, some of the data set we saw maybe more than 1 million records, it obviously won't work. You could also sort it, but if the data set is too big, you cannot do it as well. So one tool is to use the summary statistics. You have to first install the package, which the way is in my lecture notes. You could look for how to install the data analysis package in Excel. So in the data tab, click data analysis, and let's choose descriptive statistics. Let's create a descriptive statistics to see whether our data looks normal. I'm going to click OK. And the input range would be, let's first look at admission rate. And I'm going to want the label in the first row. Okay. And I will do it in a new worksheet. Summary statistics. Okay. Click OK. So this is the summary statistic of the admission rate. You can see the average admission rate for university is 68%, which sounds correct. Median would be 0.7, which is a midpoint. And a lot of the university mode means the frequency that appears the greatest, which means a lot of universities admit 100% of their applicants, which sounds a little bit weird, but it's not too unusual, so I won't suspect that there is an error there. I'm looking at the standard deviation. It's about 1/3 my mean. I look at the minimum admission rate is 0. The maximum admission rate is 1. Those sounds okay, and the count, which is the number of observation, is about 2,000 rows. I'm going to check other variables. So I'm going to create the summary statistics as I did. The input range, I'm going to check 3 variables all together, and I will do a new worksheet. Okay, generates the summary statistics. I'm just going to copy and paste this to the sheet that I have already had. So I paste everything together. I'm going to take a look at the summary statistics. I first look at the SAT average. The mean is 1,059, and the maximum 1,545, minimum 720. Some of my students ask me, why would the SAT average has a decimal? It's because this is an average of all the numbers. So we have all these institutions average being averaged. The undergrad admission 4,000 mean, which means admission 4,000 students every year is the average institutions, what the average institutions do. The maximum admission 52,000, the minimum 13. Now this minimum looks a little strange to me, because if for institution which would admit 13 students per year, that looks not very clear to me. For the cost, the mean cost is 31,806, median 28,519. So this means the average is higher than the median, which means the extreme value are on the high end. We look at the maximum. The maximum is 64,000, almost 65,000. the minimum is 4,610. So this number also looks very interesting, because given most of the universities are, the cost was almost 32,000, which university would have a 4,610? So we would probably take a look at those numbers and make sure those are not the data errors. Then I'm going to go back to the raw data. So I'm looking at the, I'm going to look at the undergrad student number. You can see there are like 13, 17. Those are the very small numbers given admissions into consideration. And I don't think we need to do anything here, because my focus is not on the number of undergraduate students. So I do not care about this variable that much. But I would look at the cost. The lower end of the cost is 4,610, and the higher end is 65,000. I'm going to take a look at what these numbers represent. So it is Puerto Rico, basically. So because they look pretty similar and they are all from the same area, so I consider it's the norm of the local institution. So I don't think it's the data error. So you should do things like this to check the summary statistics and then try to look at the data to see whether the data makes sense to you. Let's take a look at the number of undergraduate students. I'm going to take a look at the first 3 or 4. This is very interesting because these schools does not have SAT average, and their admitted undergrad students are very small, and their admission rate is 100%, which means there are only 13 students applied for this university, and they admit all of them. So if my analysis needs undergrad as the variable, I will probably look into those universities to see whether these numbers represents data error. Another way we normally do it in research, is that we look at the top 1%. I'm not sure whether you're familiar with the idea of percentile. So we usually look at the top 1% and the bottom 1%, which is the 99. So the 99 percentile and the 1 percentile, and we will either cut if they look very extreme to us. For example, like this, it's very extreme. We will cut those, which means we will delete those observations or change those numbers to the top 1% number. For example, the top 1% cutoff of undergrad student was, I'm just making it up, was 50. And then the 99% was, what was the highest number? So let's say it's 46,000. Okay, so we will actually make all the numbers that's smaller than 50 becoming 50, and then all the numbers larger than 46,000 become 46,000. So we call this method Winsorizing. Okay, so this is a method that you could be using in the future if you need to get rid of the influence of the extreme value of your observations. So okay, so in this scenario, I'm not going to do anything to my data because I figured the cost is kind of reasonable for those small numbers, and the undergraduate number of students is not my focus, so I'm not going to do too much to this database. Now I want to summarize my data management again. First of all, I would identify the questions before I even start to manage my data, because I wanted to know the variables that I need, and I don't want to throw too much information out by deleting the missing variables. One of the questions I asked in my beginning of my lecture is that how do I define high or low admission rate? Now, one of the normal practice is to use the median admission rate as a cutoff. Anything above the median would be considered high, anything lower would be considered low. You could also divide the admission rate to 3 groups or 5 groups and take the highest group as high, lowest group as low. You can define the threshold by yourself. There's no right or wrong, it's just how many observations you have left and how much contrast you want between the 2 groups. Regarding data management, I kept only the variables that I need, and I do not want to throw out too much information unnecessarily. I also changed the data types. I changed the number from number to text, for example, the ID. I changed some text to percentage, for example, admission rate, and or other different types. To change the data types, you need to read the data dictionary to understand each variable, what the types it should be. Is it a date? Is it a number? Is it a decimal? You have to decide by the nature of the variable. How to treat null values. We discussed 2 different cases. In the case of admission rate, when admission rate is null, we assume that the university did not report the admission rate. It is not because admission rate is 0. So we do not want to replace the missing admission rate as 0. But in the case of Chinese companies who did not report donation expenses in their footnotes, we know that those are the companies that do not incur such expenses, rather than they did not review their numbers. So for this case, we will replace all the null values with the zeros. Should we discard the null value depends on whether your software is compatible with your data containing the missing values, or it depends on whether you have 2 different specifications that you want to delete the null value in one to run one specification, but you don't want to delete the same observation for the second specification. If that's the case, you need to separate the data, or you need to come back and revise your data query. Finally, after I clean up my data, I change the data types, I clean my data, I want to check whether my data makes sense. So one of the ways, there are a couple ways to do it, but one of the effective way is to check the summary statistics. I always ask my PhD students to check summary statistics the first. So you should check the mean, the average of a variable. That makes sense of the data. For example, if the mean ROA of the US companies is 30%, then it doesn't make sense. It should be like 4 or 5%. How do I know which number it makes sense? Most of them coming from common sense, or you could search media to see what the normally cited numbers are, or you could check other people's research to find out what the published paper says the numbers are. And then we want to check something like standard deviation to see how scattered is my data. If the standard deviation is really high, that means my data is all over the place. So I would have to check my data if all my data is very scattered. Finally, I want to check the maximum and minimum, as what we did a moment ago. We want to see whether there are extreme values or there were some data errors. If there were data errors or extreme value that are going to be affect our outcomes, we would want to discard those observations, or we want to do Winsorizing to make those extreme values the same as their some of the cutoffs. All right, so I think this is the ETL extract, transform, and load process that I want to introduce to you in this lecture. If you have any questions, feel free to email me or bring your questions to the chat. I'll talk to you later. Bye.